everyone. My name is Mehdi Bentanfous. I'm a managing director at KINEXON Group. KINEXON developed a localization technology based on the so-called ultra-wideband technology. And with it, a localization platform, real-time localization platform to process and analyze the data. Is everyone familiar with the RTLS solutions and geolocation? Nobody? So I'll start from scratch. But today, as we're not talking about KINEXON, we're talking about how important geolocation is for the smart factory of the future, for the digitalization of the shop floor, not only the machine connectivity, also all the movable things have to be connected. And this is where I would like to show you different types of use cases. What is the value add when I connect everything it's moving within a shop floor? But before that, I want to start with a video, and I'll explain later why I'm showing you this video. So you're probably wondering why I'm showing a handball game, sports environment, nothing to do with the smart factory, actually. You saw the technology that has been used on the video. It's a sensor technology where it's placed on the player, it's placed inside the ball, and we locate these movable things, which is the player and the ball. With this data that we're collecting, we digitize actually the court. We digitize everything what's happening during the game. And so we understand exactly every movement and everything about the game, and can develop and give the coaches, the fans, the TV, everyone smart analytics, which sometimes decisions are based on. In exactly the same way, we can digitize the shop floor by locating the things like assets, equipment, vehicles, employees, to develop a location-based digital twin and know exactly what's happening in my shop floor. And based on that, not only analyze processes, but actually also automate them if needed. So it's the same procedure using so-called RTLS, real-time location technology, for geolocation purposes. And this is, I would like to show you what kind of use cases and what kind of application are relevant here. So starting with an analog shop floor, if I'm not in the need of digitizing the shop floor, I need to know where things are. And the problem is, we talked today about the machines and how important digital twin is. This has been always the focus so far of industrial IoT. When it comes to digitalization, is we progressed a lot over the years in terms of connecting the machines, managing the machines digitally. But what we forgot, or what we didn't push further, was what about the assets? What about the equipment? What about the people? What about the processes? If I connect these, which they represent almost 99% of the shop floor, then I have a complete digital picture of what's happening in my production, in my warehouse. And in that case, I can also improve procedures. And as I said before, also automate them. So when you look at the manufacturing activity, 60% of these can be automated. Now we have robots implemented, we have connected machines implemented. If I get this information about how my workflow, my material workflow, for example, is, if I know about what is my warehouse situation automatically without any manual work, I can automate these processes. I can improve my productivity and obviously also decrease the costs. But for that, we need this location data and we need the location technology to do so. So the smart factory of the future, everything is connected and everything is interacting automatically. So what happens when we connect, let's say, the worker, the assets, and the vehicles? Immediately you can imagine that there are value adds that I obviously can see in very obvious way. I understand, for example, the material flow. If I understand the material flow, I can, let's say, see or identify bottlenecks. I can improve these processes. If I have a connected vehicle and a connected worker, I can implement a safety procedure. So if I know where the vehicle is and I know where the worker is, automatically I can do a warning or an alarm setup to prevent from a collision, for example. So just thinking about it quickly, there are so many applications that can be done if I'm connecting everything on the shop floor. When it starts with, first of all, how do I connect? There are many different technologies out there. Very known technology, the classical one in the outdoor is the GPS. If you look at the indoor, which always has been a problem, because GPS doesn't work indoor, and for a high precision of data, there aren't that many. Wi-Fi and Bluetooth, they are progressing or evolving, but they still don't have enough or a certain accuracy of the data in order to implement more than a search and find application, so to say. So what KINEXON developed was a so-called ultra-wideband technology, or let's say a solution based on ultra-wideband. Ultra-wideband is radio frequency based. We use these anchors as so-called satellites. And with a high bandwidth radio frequency, you're able to exactly locate things, an asset, a pallet, a vehicle. As you saw before, I even can track a handball with a high speed with a sensor inside of it. So now I know exactly centimeter accurate where things are. And the number of use cases that I have expand exponentially when I have this type of precision. So we start with building a sensor network around the area we're tracking. And then we place different type of sensors on the movable thing that we talked about. Now, this, as I said, this is a technology that is superior, is very accurate, and it's also expensive. So we need to see what kind of use cases can we use ultra-wideband, or maybe alternative ones like Bluetooth, sometimes even the passive RFID, or the Wi-Fi. Talking about the use cases, in this case, when we talk about asset tracking, right? Classical asset tracking, and high-value assets, pallets. I have different applications in order to optimize the material flow or also to automate it. For instance, using e-paper sensors sensors that also display further information about the asset itself. I can implement a paperless production. No papers, no scanning. I have the information on the assets. As soon as the assets enters a certain area, I have the additional information displayed on the assets. This information is also automatically then sent to any third-party system, like a warehouse management system or MES system, for instance. Classical search and find. A lot of companies and large companies, if you look at the aerospace industry, for instance, the aerospace industry, most of the business in the production sites is for maintenance. And one of the biggest problems for them is they lose things, they lose equipment, they lose high value components. And just reducing the time or locating things easily increases the productivity, decreases the resources, and also increases the throughput time. So search and find, which is a very standard or easy case for location, has already a huge impact on my cost, on my productivity. And the classical also track and trace. I know exactly how the workflow process is. I know exactly where are the bottlenecks. I know exactly where I need to improve the process because I can basically map the process or through process mining, I can model the ideal process and map it with the real process that's happening and identify the gaps, identify the bottlenecks, and automatically then improve it. Automatic ID, with the sensor has, or the tags have also more than the location position. So in this case, you're able to identify the assets wherever it is. You don't need any scans, you don't need any bookings, and that reduces not only the resource time, but also the error and the quality, obviously. Moving to another tracking when it comes to the vehicle tracking. The vehicle tracking, there are two different types of applications. The one is the safety, the monitor, the control of the vehicle. And the second one is more about the productivity part. This one here, since I know in real time and very accurately where the forklift is, for example, I can prevent collision by warning. I can even, knowing where the forklift is in a certain area or danger zones, automatically reduce the speed. I can open doors automatically, if no need for any manual work, or even traffic management if I have different types of forklifts and AGVs or other carriers. So that's the part where there is a control or automation of the environment, but at the same time, I'm able to analyze and improve the effectiveness. Now I know I can optimize the order, but also I can optimize the route. I can optimize the usage of the forklift. I know how much time, or how many forklifts I have. I know how much time are they in usage, and automatically, or in that case, I can define, do I have the right fleet or not? So I can reduce the cost as well. From assets to vehicle to workers. I'll come later to a use case that we had within this pandemic, but even if I'm tracking the workers, I can identify if there is something wrong. I can combine it with a forklift tracking and then have a collision warning that's happening. We did an implementation in Mexico where forklifts has been a big problem with collisions, with incidents with workers, with the system implemented, and because we have very high precision, but the data is also provided in real time, meaning within milliseconds, it's very easy then to give a certain warning and prevent from collision. Access management, visitor management, in this case, identify who is basically where within a certain area. Are the people in an area that is prohibited or restricted, and so on. So I have also the worker flow as well digitized. Same thing, as I mentioned, the danger zones, walkway analysis, but even cost allocation. I know how long is the worker working at a certain station. And the intralogistics is pretty interesting. Companies like DB Schenker, now they want to know where exactly, how much time is my worker working on a specific project, because we know that this station is for client XYZ. He can basically invoice the client based on the time that the worker has been working on that. So that can be also automated and doesn't have to be done manually. The same technology is also the collision warning, as I mentioned before. The same technology has been last year through the pandemic, and since we have the location data, has been used for contact tracing and warning. If two persons have a sensor and they get too close to each other, you have then a warning, and in case of an infection, you identify who might be at risk. So the number of use cases that can be used when you have the location of something is basically unlimited, and it goes from, as I said, analyzing for safety as well as improving and automating. That's one of the use cases we had. Our implementation we did at KINEXON was with Continental. The vision of Continental was also the same as I need to connect whatever I have on the shop floor in order to understand what's happening and in order to improve my processes. The biggest problem was I do not have enough visibility. How can I achieve that? And together we implemented step by step, as I explained before, from putting the sensors and the sensor network to implementing our platform and providing a digital twin of the shop floor, to then advanced analytics, predictive and advanced analytics to analyze what's happening, and then step by step improve every piece of their process. So at the end, you have an end-to-end autonomous material flow. Autonomous means that there is no manual work other than what is needed or productive time, and all the time that is used or resources used not to produce or for productivity purposes are then eliminated. In this case, we implemented the technology in different areas, but also with different sensors. So as I mentioned, we have the asset and vehicle tracking. We track over 3,200 assets in one location and more than 50 vehicles. Now I know where my vehicles are and even whatever they are carrying, and I can basically define geofences. Means, as you can see here highlighted, the different areas. I know exactly when my asset is in the internal material supplies. I know when how much equipment I have in the buffer zone, and so on and so forth. So just as an example, in this case, from the logistics center, we have the pallets loaded with material that goes to production. It is stored in the buffer zone and before the production. If we don't know, and there is no scanning process, and we don't know what is moved from the logistics center to the production area, first of all, we don't have any transparency. Second, it can happen that you have an overload in that area and nobody knows, and basically equipment has to be sent back. If I want to implement the FIFO principle, it is manual work, so it's not guaranteed that it really happens because no one is checking and monitoring the process, and there is no information about the downtime because there is no visibility at all. So imagine you have these pallets with a sensor, and you have these areas, the logistics center and the production area, as geofences. As soon as one pallet enters the production area, it is recorded in the system, and at any point of time, we know how much equipment is in the storage, when is the storage or the equipment leaving the storage to the production, when do I have to refill, and if there is any downtime, I can react immediately. So, and this is happening, everything is happening in real time, so that the reaction time is basically instant. So we can see that not only I can improve the process, but I can actually increase the quality and the throughput rate, and at the same time reduce the costs by eliminating the scanning, booking process, all the manual work, as I said, that is not meant to improve the productivity, but it's actually manual work that is not needed. Here are a few impressions of what we have been tracking within Continental. You see the internal material supply in the buffer zones, the equipment. We have the AGVs that or the AGVs and the forklifts that are equipped also with the sensor, and the whole sensor network that is placed in the whole production area. And this is basically just one use case. Now, if you have the infrastructure, you can add use cases, add sensors to other equipment, and basically the return on investment and then even higher, because with one system, you're actually covering many use cases at the same time. And as I mentioned before, ultra-wideband as a technology. In the last few years, ultra-wideband has been a very expensive technology, and over the years, we try to reduce the costs as much as possible. It is a very reliable one, using basically the radio frequency or high bandwidth. You don't have any interferences with any other technology. So it doesn't matter in which environment, you always have very high quality of data. And at the same time, it's very precise. We were talking about 5 to 10 as below 1 meter, and it goes down to 5 to 10 centimeter in a very high quality case. You can compare it to Wi-Fi and Bluetooth, which is between 4 and 6 meters. So there are many use cases that you cannot implement Bluetooth or Wi-Fi, or RFID or passive RFID is just provide you with a selective location, but not a continuous one the whole time. So ultra wideband is for the shop floor and for the factory and for the continuous tracking of my assets and vehicles. Is the best technology out there. And today, actually, we are announcing as KINEXON the launch of our new ultra wideband tag. So it's just by surprise that it's today, which is we're lowering the cost as much as possible to come to a level where Bluetooth, would at the same time, same price level as Bluetooth. In this case, it makes a lot of or many applications very affordable, and the implementation of ultra wideband will expand in the future in different industries. To finish here, just an overview of KINEXON. We've been now in the market since 2012. We had more than 600 projects in 12 countries and in different industries. Automotive is obviously one of the industries that we focused on in the past, but the technology is used or can be used and should be used in any other industry out there, from aerospace, retail, logistics, electronics. The digitization level in the different industries is not the same, but we see efforts and interest in the markets for localization and geolocation increasing significantly over the last few years. And with that, I close my presentation.